So now we're going to get into absolute value equations. Instead of just a basic intro where it's always going to be the same number, positive or negative, now we're going to get into a one-step, a two-step, and a multi-step equation within the absolute value as well. So if you remember from the last lesson, we said the absolute value of n is equal to 5. Well, inside those absolute value bars, they're asking what number can you put inside the absolute value bars? Well, to get 5, we're saying, 5 spaces away from 0. Well, remember, we can take the absolute value of 5 and get 5 for an answer, but we could also take the absolute value of negative 5. So basically, this n, who's in the middle right here, can equal a negative 5, or it can equal a positive 5. So we wrote that as n is equal to positive or negative 5. Well, that same concept goes to these equations, except now I don't just have an n inside the absolute value bars, I have n plus 2. Well, it's still the same concept of absolute value. If I'm saying the absolute value is equal to 6, then everything inside of here, if I covered this up, I'm just saying what can be inside these absolute value bars and get 6 for an answer? Well, I can take the absolute value of 6 and get 6, or I can take the absolute value of negative 6 and I can still get 6. Over here, it went straight to my answer because n was already by itself inside the absolute value bars. In this case, n isn't by itself anymore. So not just n is equal to 6 or negative 6, everything in here has to either be 6 or negative 6. So inside those absolute value bars, I have n plus 2. And in order to get 6 for my answer, that means that n plus 2 can equal a positive 6, or I can also take the absolute value of a negative 6. So now with absolute value, we're going to have compound equations. I'm actually going to have 2 equations put together as one. Because with absolute value, remember I can take the absolute value of a negative and I can take the absolute value of a positive and still end up with that 6 for my answer. So now, well, I need to figure out what n equals. So if I want to get this n completely by itself, I have to get rid of that 2. So to get rid of a plus 2, I have to minus 2. But what I do to one side, I have to do to all sides. So over here, same sign, add and keep, I get a negative 8. In the middle, I still have that n, and 6 minus 2 is 4. So n can be a negative 8, or n can be a positive 4. I can check that answer by plugging it back into the original problem. So on your homework, if it says check, you have to make sure you actually check the answers. So up here I have the absolute value of n plus 2 should equal 6. And instead of n, I should be able to replace it with either one of these numbers. So let's try the negative 8. I'm going to erase that n and I'm going to put a negative 8 because that's one of the answers we came up with. Well, negative 8 plus 2 is negative 6. Well, hang on a second. Negative 6 doesn't equal 6. But remember, it's in the absolute value bars. And the absolute value of negative 6 actually does equal 6. If I plugged in that problem again, the absolute value of n plus 2 is equal to 6. But now instead of negative 8, it should also work if I plug in a positive 4. So I'm going to erase the n and plug in a positive 4. 4 plus 2 is 6, and the absolute value of 6 also equals 6. So it actually does work with the negative 8 or a positive 4. So let's try this one. Everything inside these absolute value bars should be able to equal 14. But remember, I should also be able to take the absolute value of negative 14, and I still get 14 for my answer. So everything inside these absolute value bars, the 2x plus 8, should equal a positive 14, or it could also equal a negative 14. But I need to solve this all the way through to figure out what x actually equals. Well, now this is just a two-step equation that's a compound equation. So the 2 and the x will still stay together. To get rid of a plus 8, I have to minus 8 on all sides. These ones are same sign, add and keep. I should get a negative 22. In the middle, I still have 2x, and 14 minus 8, I get 6. So for my final step, I have to divide by 2. So I get negative 11 is equal to x, or x is equal to 3. If you're filling out the answer, I would be okay with you leaving your answer exactly like this. If it's multiple choice, they probably won't have it in this format. So you just have to pick the answer that means the same thing. Well, right here, this is saying x is equal to negative 11. And right here, it's saying x is equal to 3. So if it's multiple choice, they'll probably separate it into two separate answers. I would accept either one of these for a final step in my class. So the last example for our absolute value equations has a little bit of everything. It has the absolute value of a two-step, plus it has a little bit extra, and equals 15. Well, when we're dealing with absolute value, remember inside these absolute value bars, we can take the absolute value of a positive number, or we can take the absolute value of a negative number. But we can't go straight to making it 15 and negative 15 like we did in the past, because only the absolute value can be a positive or a negative inside. So whenever you have anything extra, we have to actually get rid of that first. So I have to get rid of this negative 6 because that's my extra in this problem. And to get rid of a negative 6, I would just add 6 to both sides. So when I bring everything down right here, I still have the absolute value of 3x plus 9, and the absolute value is equal to 21. So now that I have the absolute value by itself, they're asking what can I take the absolute value of and get 21. Well, that's when we can separate it into two, or one compound equation. It means everything inside this absolute value bars can be 21, because I can take the absolute value of 21 and get 21. But I could also take the absolute value of negative 21 and still get that 21. So only what's in the absolute value bars is what's going to equal the positive or the negative. So make sure anything extra, we have to get rid of that first before we separate into the compound. If you follow that step, everything else is exactly the same as we've already been doing. To get rid of a plus 9, I minus 9, and what I do to one side, I have to do to all. So same sign, add and keep, I get negative 30, is equal to 3x, which is equal to 12. For my final step, I have to divide by that 3. So negative 30 divided by 3 means x can equal negative 10, or that x can equal 12 divided by 3 is a positive 4. Remember, I should be able to double check and plug that number back in, and it should still work. So if I plugged in negative 10 back up here instead of x, this should still all be true. Well, 3 times negative 10 is negative 30, and negative 30 plus 9 is negative 21. The absolute value of negative 21 makes it positive 21, and 21 minus 6 will still get me 15. So if you're ever doubting yourself whether your answer is right or wrong, make sure you take that answer and plug it back into the original problem. And if you're right, it should work.